In this presentation, we'll learn the difference between incomplete dominance and codominance, and also how to complete a Punnett square with each of these types of multiple alleles. Here, in incomplete dominance, you see that the red flower plus the white flower would cross to create a pink flower. There, you see a blending of traits. With codominance, on the other hand, you see the white flower and the red flower create a red and white flower. So you see both traits here. In codominance, both alleles are dominant, whereas in incomplete dominance, neither allele is dominant, nor is it recessive. So, if you see a red people eater mates with a blue people eater, and they have a baby, which is a purple people eater, is this incomplete dominance, or is it codominance? You look here, red and blue blend to make purple. So in this case, this is incomplete dominance, because there's a blending. In order to do a Punnett square, there are no lowercase letters. So when you look at this, you'll have the genotype for the dad here would be red, RR. The genotype for the mom here is blue, BB. The baby has a blending of those two genotypes, so she has a red, blue, or RB. In a Punnett square, it would look like this. The father would be R, and the mother would be B. Together, they would have only purple babies, because each allele blends, and you only have RB as the result in the Punnett square. So a blue plus a red would only give you purple. Let's practice. Once a baby purple people eater grows up, he meets a lovely blue people eater. What is the chance that the blue and purple couple will have purple babies? So we need to see the baby people eater is a boy, and he has a blue mate. So the mother's going to be blue, so she's going to have big B, big B. The baby purple people eater has RB, because the red and blue make purple. So we'd have to see together what they could have. Here we have RB, BB, RB, BB. So these two have a 50% chance of having a blue purple eater baby, a blue baby, and they have a 50% chance of having a purple baby. There is no way this couple could have a red baby together. Okay, another practice. A red fish and a blue fish mate to create lots of little blue fish with red spots. Is this incomplete dominance or codominance? In this case, we have codominance, because both traits are shown. The blue plus the red make blue and red. So you see both alleles. Both are dominant. So to look at this, the red, again, it's going to be very, very similar to the incomplete dominance to complete a Punnett square. The red dad will be big R, big R. The blue mom will be big B, big B. And the spotted baby will be big R, big B. That shows that you have a blue and red spotted baby. So if we put the father's genes here, we see we have big R, big R. And the mom's genes are big B, big B. Again, same as when we do the Punnett square for incomplete dominance. We have R, B, R, B. Each time, we are going to have a purple baby. R, B, and R, B. Each time you see, we have no chance of the red and the blue together, making anything but a red and blue spotted baby. Okay, a blue fish mates with a blue and red spotted fish. Can this couple ever produce a solid red fish? So let's do a Punnett square with that. We know the blue and red spotted fish is going to have the genotype RB. A blue fish is going to have the genotype BB. So when we cross those RB and BB, we have RB, BB, RB, BB. So could they produce a solid red fish? That is our final question. No. They have a 0% chance of producing a solid red fish. So a blue fish plus a blue and red fish could not produce a solid red fish. One of the most important examples of codominance is blood type. You look here, you see that type O blood is little I, little I. You can see that that is the recessive trait. When you see type A blood, you can have I with a big A, I big A, or I big A, little I. For B, really similar to A, it's I big B, or I big B, little I. For AB, the only genotype possible is I big A, I big B. This is very useful when they are trying to do paternity tests. Long ago, they had babies switched at birth. That could be taken care of by looking at the blood types of the parents. So here's a practice problem. By some ridiculous mistake, two baby boys who look a lot alike are switched in the hospital. Jolie has type O blood, and her husband Jake has type AB blood. Baby 1 has type AB, and baby 2 has type A blood. Which baby is most likely Jake and Jolie's baby? So the first thing you need to do is look at the mom's genotype is type O blood, so she can only be little I, little I. And dad has type AB blood, so he has to be type big I A, big I B. Makes it kind of easy to cross them. There's only one genotype possible for each of them. So the baby 2 has type A, and baby 1 has type AB. Let's see which one is possible with Jolie and Jake. So here we have IA, little I, big B, little I big A, little I, B, little I. So the only possibilities of blood types for these two are type B or type A. You can look here again. When we look at these, we see that type A or type B. So I'd have to see here, baby 1 has type AB blood, so baby 1 cannot belong to Jake and Jolie. Baby 2 belongs to Jake and Jolie. They could not have a baby with type AB blood. And that is it for incomplete dominance and codominance.